Hi, welcome to video 611 on mixed modeling. We're on page 16 of your purple packet. So in mixed modeling, we're talking about all of the different functions that we have learned about, or many of them. The reason why we learn about these functions is because there are things in the real world that go with these functions that act like these functions, and then we can use them to predict things. So we're going to be looking at a number of situations and choosing the model or the function that best goes with it. So for example, we've got a taxi situation. So orange taxi charges $2.75 when you step into the taxi, and then $2.50 per mile. Magenta taxi charges $3.25 just for a ride, and then $2.50 a mile. And so we're going to describe a function for orange taxi and one that is magenta taxi. So when we have something that is increasing at a constant rate, that's going to be a linear function. So we're going to use our y equals mx plus b parent function to write our functions for these. So orange taxi, f of x equals, our slope is going to be our constant rate of change, which is the 2.5. So 2.5x plus our y-intercept is at 0 miles. How much do we spend? And that's $2.75. And then magenta taxi is g of x equals, they have the same constant rate of change, 2.5x, but $3.25 for the y-intercept or the initial cost. So the type of model we used was linear. And then the next part I'd like you to think about, so without graphing, see if you can explain how you think these two will look different and the same from each other on the graph, and then graph it and give it a try. Pause the video and come back and I'll show you how it looks. Okay, these guys were parallel to each other with g of x being above f of x, and that's the way they look on here. The reason we could tell that was because if their constant rates of change are the same, they're going to be parallel. They will never intersect with each other. And this one had a higher y-intercept, so it's going to be a little bit higher up on the graph. Okay, let's take a look at the next one. So this one right here, this guy is cutting a piece of paper in half over and over again and getting rid of the half, getting rid of one half. So each time we are halving the area of the paper. So cut it in half and it's 75 square inches. Cut it in half, 37.5, 18.75, 9.37. And I did those ahead of time on a calculator. So if we were to graph the points from the table, would we connect these points? And this is the idea of whether it is continuous or discrete. And continuous means that in between points, you could predict things in between points. So for example, we could have like 1 cut, 2 cut, and then like cut 1.5. Whereas discrete means that we're only talking about individual situations. So like cut 1 is this, cut 2 is this, and there's nothing in between this. So in this case, no, we would not connect the points because these are discrete occurrences, and there's no half of a cut, no 1/2 cut, or no 1.5 cuts, or anything in between those. What's a reasonable domain for this situation? So remember, domain is x, so we're saying what is a reasonable, like what's the lowest and what's the highest number of cuts we could have? Well, 0 is going to be our lowest. 0, because you can't have negative cuts. And the highest, I am guessing, I would say about 10. You can't go too high because if you cut a piece of paper in half and in half and in half again, eventually it's going to be too small for you to actually cut. So we could keep finding the area, but it would be theoretical. You couldn't actually figure it out. So we'll say about 10 because too small to cut. And we'd have to experiment with a piece of paper to see how small was too small to cut. Okay, this one is really asking us what we already did in B. So we're going to say, no, it's not continuous, it's discrete. And we're going to say C Question B. Okay, so our y-intercept, remember if we're looking at our graph, the y-axis, all along the y-axis, x equals 0. So when x equals 0, that's going to be 150. So our 0, 1, 50 is going to represent the original area before any cuts were made. And we're also going to identify the absolute maximum, which is the same thing. So because this is the highest point, the highest area, it's representing the same thing as E. Okay, the next part I want you to try. So looking at those numbers, thinking about this situation, what family do you think it's going to belong to? Is it linear, quadratic, exponential, absolute value? Give a guess and then graph those numbers to see if you're correct and come back and I'll show you what it looks like. Okay, so this is what it looks like. It is exponential because we're multiplying it by the same thing, which is 1/2. Or you could think about we're dividing it by the same thing, dividing it by 2 every time. And that's what mine looked like. I counted by tens. Yours might look a little different depending on your scale. Okay, so moving on, this time we can see the function. They're giving us a quadratic function. They've got some individual pens that we're looking to build, and they have 90 feet of fencing to surround and divide the pens. And so that's how they're deciding to use it based on this equation. So we're going to determine the zeros of this function, which means we're going to factor it. So a equals 0. 45x minus 3x squared. So in this case, it looks like we're going to just take the GCF, which is 3x. So 0 equals 3x. This divided by 3x is 15. That divided by 3x is just x. So if this equals 0, then x equals 0. If this equals 0, then it's 15. So it's going to be x and 15. So that means if we're kind of picturing it, this is going to be 0, this is going to be 15. It's going to go like that in between. So how can we use this answer to help determine where the x value, where the maximum is going to occur? Remember, quadratics have an axis of symmetry, so it's going to be exactly in between those two. So the maximum will be halfway between 0 and 15. So let's go ahead and find what that's going to be. We're going to find the maximum area of the pen. So we have to find our x value first. So we're going to do 15 divided by 2, and that gives us 7.5. So that means our x value is going to be 7.5 when our area is maximum. So we're going to substitute that into our formula here. So we've got 45 times 7.5 minus 3 times 7.5 squared. And I did this earlier on a calculator, so this is 337.5 minus, this part is 168.75, and that gives us 168.75 square feet, so that's our maximum area for this case. Okay, let's take a look at the next one. So here we've got area A of an oil spill is increasing, and they're trying to model it as a function so they can make predictions about it. So here is the data points that we have so far. And this is saying that a linear function is not going to be a good fit. Let's see why. So if it's linear, it would have a constant rate of change, meaning the numbers in between here would be the same. This is 0.9, 1.1, 1.3, 1.7. They're all kind of close together, but they're pretty clearly increasing each time. So a linear model is not going to be a good fit for this data because there is no constant rate of change. Okay, so they're saying that an exponential function does fit this data well. And we've got this format, and we have these choices for A, and we have these choices for B. Okay, so A is actually going to be really easy, and here's why. When I have anything to the 0 power, that makes it 1. So when this is 0, this is going to be A. Let me show you. So if I have anything times A and then B to the 0, that's A times 1. So if I have 0, 3.5 is going to be my A. So that's going to be my A. And then here, what we can do is we can see by how much this is increasing. So if I took 1.1 divided by 0.9, I get 1.25, something very close to that. So that's where I'm getting my 1.25. I'm seeing each time how much are you multiplying by every time in between there. Or I'm sorry, I didn't take this divided by this. I took 4.4 divided by 3.5 because I'm seeing what I'm going to multiply each time to go up. So this is going to look like A equals 3.5 times 1.25 to the t power, which is our number of days. Okay, moving on. All right, this one. So we're looking, it's saying that a quadratic function is going to work. If we look at this, we can see this goes up and then it goes back down. Out of all the ones we're talking about, that's either going to be absolute value or it's going to be quadratic function. So it's got to be quadratic since that's what they're saying. So quadratic is because it increases and decreases. And a linear or exponential function will only do one of those things. Okay, so we're looking at it as a quadratic function and they're wanting us to give it in vertex form. Okay, so remember our vertex is either going to be our maximum or our minimum. Since this one is going like this, it's going to be a maximum. So all we do is look for our maximum. So that means our vertex is going to be 38.75. So H equals 4, K equals 38.75 because this is the maximum. Okay, so this one down here, this one was a little bit tougher for me at least. So what I did was I took my vertex form and I put in what I knew. So I know that H is 4 and I know that K is 38.75, and then I just took some values from up here and I plugged them into C. So for example, I did D equals 0 and P equals 30.5. And so I plugged them in and said, okay, I've got 30.5 equals A, 0 minus 4 squared plus 38.75, and solved for A. And I ended up with A equals -1/2. So that's the one I chose. And all of that right there was the reason that I chose it. And we'll get some more practice on this in class. So right now we're just looking for understanding how these were solved. Okay, I do want you to read the problem on the back and see what your opinion is about the question down here based on the information you have. So pause it, read it, answer the question, and come back. All right, so my answer on this one is that train 1 and 2 are going to get to DC very close to the same time. So I think it's difficult to tell between train 1 and 2, and it's only going to be a few minutes either way. Train 3, you're going to get there a little bit later because it's almost 8 hours that you're going to be in the train, but you're spending less time in the train because this one doesn't leave until noon. So even though you're getting there just a slight bit later, you're spending a lot less time on the train. Okay, please write down any questions that you have and we will go over them in class.